My name is Karl Weinmeister. I'm with Google's developer advocacy team. I had the fun experience of about 30 minutes before this call started, my home internet went down. So unfortunately, I'm just on audio, but we're well prepared and can just go over the slides here in audio and we'll be fine. I'm going to kick off this presentation for basically in thirds. I'm going to start with it, kind of kicking off a little bit of the history of Kubeflow and all the cool stuff about what's new in 1.0 is what's going to be covered by Josh, and then Elvira is going to get into a little more detail on just how to build pipelines and I think a pretty cool demo at the end. So with that, let's get started. Elvira, let's go to the mission statement, slide 2. As you've probably heard from David and others who've been involved with the project for a long time, one of the great things about this project is the mission statement has stayed constant over the years, kind of always having that North Star. And I really think this is one of the best mission statements I've seen. In one sentence, it really summarizes all the different goals of the program. So kind of starting from the beginning, making it easy for everybody. Providing, standard out-of-the-box images to just get up and running easily, and that keeps improving each release. Also covering every part of the life cycle, right, from development, deployment, and management. And finally, taking advantage of the Kubernetes infrastructure by helping make your ML workloads portable, on-prem, different configurations of machines, taking advantage of the distributed nature of Kubernetes for training and serving and scalability. So I really help fill a very important need in organizations. And I might add also with software development and application development becoming very, very commonly using Kubernetes, it's great when your ML and your standard sort of app development work can be on one infrastructure. So that's the mission of Kubeflow. This slide here, on the next slide, we have sort of this spider diagram of all the things Kubeflow does. And what's neat is that in 1.0, and over the years, we've seen this whole spectrum of things that are needed for ML get filled out. And I'll quickly walk through the diagram. I think kind of starting from the top and kind of working our way clockwise walks you through the whole life cycle, right? So Jupyter Notebook's kind of a must-have in terms of your IDE for data scientists to prototype and to build notebook, basically ML code there. Your training operator, so taking advantage of the Kubernetes constructs to enable TensorFlow, PyTorch, XGBoost, all kinds of modeling frameworks to operate on Kubeflow, kind of in the Kubernetes way. Workflow building, so with Kale and Faring, putting some of those steps together in workflow, and then pipelines, which is an exciting part of the project. A lot of activity has been happening there recently. Your ability to create a reproducible machine learning workflow, right, from extracting data to building your model, validating it, deploying it, doing things like model retraining, and you're seeing now enhanced integration with TFX, multiple kinds of runners. So it's really becoming a robust environment to create not just the model, which is a piece of the puzzle, but the end-to-end workflow. Then data management, right? Clearly data, matching the data you use for an experiment to your model is key. Needing to version that, securely store it, and so forth is critical. From a tooling perspective, there's capabilities like hyperparameter tuning. So being able to take advantage of the scalable nature of Kubernetes to do these massive searches across your parameters to create the optimal model. And then there's some just other capabilities, things like TensorBoard for debugging your TensorFlow models, or Prometheus, so the Kubernetes logging, monitoring infrastructure, being able to take advantage of that is great. One of the things that we've added recently is metadata management. So as you build out your pipelines and such, you can store metadata, call that metadata API, which version of the model was this, what date was it created, other custom metadata that you want to associate with that. And finally, serving, which, I think is a critical piece that often is kind of overlooked in that, if you have a successful ML project, although serving or inference doesn't usually take as much compute, there's much more a higher volume of it than training, right? Training you do maybe, occasionally, and it takes a long time, but serving, certainly you need to scale up, if it's a successful ML project that's integrated into your business applications, having a robust serving infrastructure is great too. And so, we see our partners like Selden, TF serving, and most recently KF serving capability, different ways to serve up those models as REST APIs and make them available in your application. So that was kind of a very fast kind of walkthrough of all the things that are coming together here now in Kubeflow 1.0. Let's go to the next slide to look at the little bit of a history of Kubeflow. And I won't talk through all the different releases and features here, but you can see from the beginning, the individual applications were starting to be created, in the first year or so, putting together the workflow infrastructure, supporting hyperparameter tuning, adding Jupyter notebooks and such. Then over kind of the next third of the project or so, you started to see connecting the apps, right? Pipeline capabilities come into Kubeflow. And then finally, where we're arriving now, over the last couple of releases, a lot of hardening, productization work, right? So in Kubeflow 1.0, there really wasn't a lot from a feature perspective, right? That was by design. We wanted to really make sure the features that we had were production ready. So that's where we are today, and you can see all the great things that have been added and improved over the years to get to where we are today. So let's now go to the next slide, please, on community. What's great really about this project is it's had a very diverse, wide set of contributors that have all made it happen, contributing in different key places in the project. And you're seeing this healthy growth of the project, number of PRs growing, kind of a broad set of contributors. So it couldn't have been done without the community that's been built. And finally, let's go to the next slide. And this slide really, I think, summarizes why Kubeflow, right? Because, often, at data science conferences and in marketing, we just hear about, how to create models. And, that's kind of often seen as the essence of what data science and data engineering is. But, it's kind of what you see on the left. But the reality is, we all know as we're, on this call and believe in Kubeflow is putting a model in production is so much more than that, right? That, making sure that all these data sources that are we're extracting data from, that we can trust those data feeds coming in, that we have the validation coming in, that we have, the same version of TensorFlow running on all of the different machines, that, everything is reproducible in a pipeline, right? Each step of the process. Can it be monitored? Can your infrastructure be set up, in a consistent way across different environments? All these different things that are required to put something that's mission critical, which many machine learning applications are, that are making important decisions with the data, that they're as reliable as any other piece of application development software. So that's what we put together here in Kubeflow. So with that, I want to turn it over to Josh to talk more about what's in 1.0.
Hey, Karl, thanks for warming up the audience. Look, in the Kubeflow 1.0 sprint, the community has worked hard to develop code and deliver new features. Maybe even more importantly, the community has also approved and implemented processes that help set user expectations and ensure code quality. For instance, the community's process includes publishing a roadmap, which outlines the features and timing for the next Kubeflow releases. In this case, it would be 1.1. We're also have developed a versioning policy that defines and validates the maturity level of each component into stable, beta, or alpha. The stable components have been built to satisfy the community's application requirements. Each stable component has its own requirements, but starts from an application requirements template, which includes configuration and deployment, the custom resources that it may be using, logging and monitoring, Docker images, CI/CD, documentation, testing, ownership and maintenance, as well as user adoption. The community tracks its progress using Kanban boards, which is a great source of information for users who are interested in the direction of the project. As you can see, Kubeflow 1.0 was one of the largest Kubeflow releases with nearly 200 issues closed. And most of these were features that were designed to improve the fit and finish as well as the end-to-end CUJ workflows. Please review the chart at the bottom of the page, which lists the stable and the beta components in Kubeflow 1.0. You'll see that 8 components have graduated to stable, and we expect that more important beta components to graduate to stable in 1.1 timeframe. That includes things like Kubeflow pipelines. Kubeflow enables CUJs that include several Kubeflow components. Let's take a look at a couple of those CUJs. The community realizes that repeatable workflows are important to efficient model building. The community has already developed 2 critical user journeys to support this requirement, including the core CUJ, which has 4 steps: develop, build, train, and deploy. As shown, the core CUJ enables the users to leverage Jupyter Notebooks to develop their model code and then use a workflow automation tool, Fairing, which provides a Python SDK to build containers and create Kubernetes resources to train and scale their models. And then use Fairing again to deploy and scale their models using KF serving. This end-to-end CUJ helps data scientists produce models more efficiently by initiating and training deployment actions from a notebook. You can try the CUJ using the MNIST example shown at the bottom, and Elvira will be walking you through this example in a few minutes. The notebooks to pipeline CUJ optimizes ML productivity so you can train, version, and reproduce models faster and more consistently. In the notebooks to pipeline CUJ, Kubeflow leverages Kale and standards-based Kubernetes storage integrations to enable researchers to develop ML code and then quickly create, run, and explore pipelines using Jupyter, Kale, Rock, and Kubeflow pipelines. Kale is a workflow automation tool that simplifies these steps, and it also eliminates the need to manually build Docker containers, write YAML code, or pipeline components, or even pipeline DSL code. Kale leverages Rock to automatically take snapshots of your complete notebook, both the code and the data, and then builds and runs a containerized pipeline, which you can view and manage in Kubeflow Pipelines UI. With one click, you can reproduce the data and the code of any step along the way. As leading Kubeflow users have reported, versioning your ML steps enables for faster iteration and exploration, and this enables you to quickly evaluate, debug, and improve your models. This CUJ includes a popular tutorial, which was first released at the workshop at KubeCon San Diego, and this hands-on experience helps folks to understand the automation and versioning benefits of the CUJ. As you've seen, Kubeflow notebooks are the first component of each CUJ. Let's take a little closer look at Kubeflow notebooks. Kubeflow notebooks provide valuable operational and model building benefits for data scientists and IT operators. I'd like to highlight 5 benefits for the data scientists and a few for the IT operator. First, for the data scientists can benefit from self-service configuration, as they can easily pick the processor type, GPU or CPU, and then pick the size of the processor and the RAM. Second, Jupyter notebooks support ML model training operators, such as for TensorFlow, PyTorch, XGBoost, etc., as well as a variety of magics, TimeIt, Matplotlib, and other valuable extensions, NBDev for code navigation and editing, hyperlink documentation creation, and a visual logger for debugging. All this plus the fact that it supports TFX libraries, which are very valuable when you're building your models. Third, the access to data is critical, and data scientists can access external data sources faster by using the secrets that are stored in the notebook server. This eliminates the need to remember passwords, speeds the access to data sources, and avoids manual steps that are used outside of notebooks. Fourth, data scientists can protect, share, and restore all of their work. Using persistent volumes, a data scientist can protect all their notebook and their server components required for reproducibility. This includes their ML notebook code, their downloaded libraries and packages, their data sets, and their metadata. With persistent volumes, the data scientist has the tool to simplify their compliance, auditing, and reproducibility requirements for Jupyter notebooks. And fifth, as reviewed in the CUJs, Fairing and Kale enable data scientists to complete their workflows from inside the Jupyter notebook. This saves time and provides for more consistency in model building process. This comprehensive set of capabilities provides a valuable interactive development experience and effectively delivers a superior machine learning IDE for data scientists. Now, for the IT operator, Jupyter Notebooks, along with the underlying profile compiler, leverages secure user isolation using Kubernetes namespaces. This solution, along with its integration with Istio and Dext, enables enterprise-grade user authentication with LDAP and AD and other popular user password systems. From an architectural standpoint, the use of persistent volumes enables sharing of data sets between Jupyter Notebooks and other Kubeflow components, as well as with other users. It also enables notebooks to use smaller images and put data sets, especially larger data sets, into persistent volumes, which helps to stabilize notebook operations, avoid notebook crashes, improve productivity, and add in the data protection that you need for reproducibility. As you've seen, the Kubeflow contributors have worked hard to deliver a mature and stable version of Jupyter Notebooks, which is critical to your CUJs. And now Elvira will dive a little deeper into the rest of the core CUJ. Elvira?
Thank you, Josh. I hope that you can hear me now. So, right, now you have your model code ready and developed step. You obviously need to train this model code somewhere. So usually it takes some time and manual process for a data scientist to port his code from his local machine to the server machine, whether it's on cloud or on premise. So Kubeflow provides a component called Fairy that actually helps easily package machine learning training jobs that will enable machine learning practitioners to easily package the ML model training code and their code dependencies as a Docker image. Also, it gives ability to easily train machine learning in a hybrid cloud environment. So it will provide a high-level APIs for training machine models to take it and needed to run training jobs in the cloud without needing to understand the underlying infrastructure. And usually data scientists are not that good with infrastructure complexities. And also it gives us streamline the process of deploying a training model eventually. So it will make it easy for machine practitioners again to deploy trained machine learning models to a hybrid cloud environment and use it as for the serving step. And this all can be enabled from the Jupyter Notebook with just a few lines of code, which is amazing. This is the environment where data scientists used to work on. And of course, for IT operators, it's just a great tool to automate machine learning cold image builds and have a consistent repeatable delivery process. So now you got your image on the server machine, and of course, now you want to train your model. Kubeflow provides a variety of operators, as our user survey that we conducted last year shown us most used machine learning frameworks such as TensorFlow, PyTorch, and many of others. They all most of them are available now on Kubeflow. And the amazing part of it that you can now run your distributed jobs or even a single job on a multi-user cluster with multi-GPUs on a single GPU. So in any variety you want to. This allows for data scientists to have a faster training and iteration process, as well as have a faster validation and higher quality models. You can also leverage Kubeflow hyperparameter tuner KATIF to find the best hyperparameters for your model. And for IT operator, it's again a better utilization of infrastructure and simplified management of distributed jobs. Once the model has been successfully trained, we end up on the final step when we have this model, and this model is ready to be deployed to production. And this is one of the complex steps that usually takes the most of the time of machine learning development process. This is a deploy step. It gives tons of benefits for an end user. So Kubeflow provides a KF serving tool, which is a custom resource on top of Knative. And the purpose of KF serving is, again, a really great tool that helps you to hide the complexity of Istio and Knative and all the Kubernetes and underlying infrastructure complexity that data scientists are not familiar with. So, and because many data scientists, they use different machine learning frameworks, and all these frameworks provide different APIs that you need to get familiar with. You need to read a lot of documentation, and each of these models requires special attention. So instead of doing it, we provide a KF serving interface where basically you need to set up a configurations file that you can see on the right side. And the awesome thing that you only need to change few lines of code. You need to specify the machine learning framework you use, is either it's like a scikit-learn or TensorFlow or PyTorch, and point to a place where you're storing your current trained model. And that's it. So for data scientists, it gives a great benefit, speeds up the model introduction and validation. The model can be easily developed without a deep understanding of underlying infrastructure. For IT operator, it simplifies the use of the functions, serving function, machine learning models they might not be very well familiar with, as well as it gives them ability to upscale or downsize the deployment based on the load, simplifies the usage of GPUs, and again helps to manage operation cost. And now, with that being said, I'd like to give a small demo, the demo that can be accessed on Kubeflow website. So let's go to this Kubeflow Central Dashboard UI. Central Dashboard UI is a stable component in Kubeflow 1.0 that gives you a quick access to a variety of Kubeflow components tools such as pipelines, Jupyter Notebook servers, KATIF, which is a hyperparameter tuner for machine learning models, artifact store where you can see your metadata from your different experiments and runs. And let's get started with the demo part. Let's go to the notebook servers. For the sake of the time, we have pre-created a notebook server, but let me quickly show you how you can create a new server. You simply need to set up the name, choose an image that you want to use, or you can set up your custom image. As it was mentioned before, one of the benefits that now you can set up your CPU and memory usage in one place here. And if you have some GPUs running, you can choose a number of GPUs as well as choose a type of GPU. And once you set up all configurations, you can click launch and it will create you and similar notebooks that you can see here. So now let's go to the NIST demo example notebook. We have pre-created an IPython notebook that is available under the Kubeflow examples webpage. So let's go into the Kubeflow notebook. The goal of this demo is to show you how we leverage Kubeflow, in this case, TensorFlow operators to train the model and to do distributed training. And then once the model is trained, we will do some serving with the TF serving component. And finally, we will deploy a web application that sends predictions requests to the served model. So in the first step, we download all libraries that are needed for interactions with Kubeflow and Kubernetes APIs, as well as some libraries to do some simple data scientist machine learning algorithms and coding. As a second step, we need to configure a Docker registry. The Docker registry is used to store the images that will be created by pairing. And once we created a Docker registry, a next step will be actually use pairing. Now we can actually start using pairing part. So in this example, we use a Kaneko image. We create an output map of extra files that we want to add to the notebook. Basically, we tell how we would like to run our model code on the training environment. And once we have it, we can set it up. And the next step, we will actually build the image. And we use a TensorFlow image as a base image and the custom Docker file. So now, once we run this code, we have an image built here. You can see the result. And because we now have an image built, we will also need to create a cloud storage bucket for the next step, which is distributed training. So this step is important because we need a bucket to store the trained model and to refer to this trained model in the next steps when we go to the storing part. So once you created a storage, we can now move to distributed training step. To train the model, in this example, we use a TF job operator to run a distributed training job. In order to do that, we will set up a configuration file. This configuration file requires a name for the distributed, the training name, as well as some hyperparameters for the training part, such as train step, batch size, and learning rate. And we will need to point the directory there where we will going to export our model to. Once we set up the configuration file, we can actually create a training job. You can do it in two different ways. One of the way is to use a kubectl apply command with the configuration file. But however, because we use it in a Jupyter notebook, we can also leverage the TF job client. We need only to provide the namespace where our notebook is running on currently, as well as the configuration file. And now we, by using the tfjob client.create, we just created a Kubeflow MNIST train. So once we created the job training, we also like sometimes to check whether it's run, succeeded, or failed. So we can use this kubectl command to see the status of our TF job. And again, if we want to check some training logs, we can use two ways to do that. One of the ways, again, to use kubectl to fetch the pod logs. And the second, because we use Google Cloud right now, we can use some like a stack driver. And retrieve some links to the logs there. And also for model monitoring, like performance, we might want to use TensorBoard. In order to use TensorBoard, we will need to first create a deployment to run it. So this will take to configure some configurations file where we need to provide a TensorBoard name and namespace where our notebook is currently running, as well as point to the model directory. And we also need to create a TensorBoard service and virtual service. So once the specification is ready, we can create the TensorBoard in our Kubernetes cluster. And because I run this demo several times, so it had to delete and create it again, but basically to replace it. So we can see that now it's currently running and it's been created. And once we deploy the TensorBoard, we need to access the TensorBoard. So we will set up some UI. And now the TensorBoard UI is available behind this link. So you can access the UI and use in whatever purpose you need to use it. And finally, we need to wait for a training job to be completed. TF job client provides a API that gives you a function that gives you understanding what's going on with you, like basically gives you understanding about the job status. And once the job has succeeded, we can move to the serve step. For the serving step, we again need to create a Kubernetes deployment service, and as an optional, we can configure a Prometheus monitoring configurations. For this purpose, you'll need to provide the deployment name, namespace where we run this notebook, the base path to the model, and repeat same steps with the service specification and monitoring configuration file. So once the configuration file is ready, we can again use we can create deployment, and we can see the status that it has been successfully created. And finally, we would like to test the model. And for this purpose, we have a UI, and it will be similar steps as we done for other components. We will need a UI name, namespace, and access the UI behind the IAP endpoint. And once we configured everything and we got the UI endpoint, we can go to the Kubeflow UI and test your model results. And in this case, we can check random numbers. Wow, it was once three times. I thought it's like just was broken, but no, it's working. You can see your result predictions, your model predictions, and this is it. This is how our demo works. Let me go back to our presentation. Right. So Kubeflow has a lot of users these days, and some of them will gladly to provide some reviews and feedback. We are very happy that Kubeflow these days helps for many of our customers to manage the complex machine learning workflows, as well as improve the SER and find new customers, as well as present the right product to the right customers at the right time, and simplify very complicated deployments. As for the next steps, we target a graduation of other Kubeflow applications to be 1.0, to be stable and ready, such as pipelines, metadata, CATIP, and many some other beta components. as well as continue enhancing enterprise readiness with security and upgrades. And this is it. Thank you very much for your attendance. This is the Kubeflow website for some of you who never heard about it before, and the demo source can be available here.